Let's go to page 338. This is lesson 7-7. The objective of this lesson is to learn the relationship between the roots and coefficients of a quadratic equation, and to write a quadratic equation or function using the information about the roots of graph. Okay. So let's go and start by try to solve the equation. So let's say if you have 2x squared minus 6x minus 8 equal to 0. Okay. So in this case, what you can do is, normally you can divide by 2, but let's go and factor out the 2. So you factor out the 2, you get x squared minus 3x minus 4 equal to 0. And then you do the factoring, okay? So you need to add to get a negative 3. You have to multiply to get the negative 4. So you're going to get 1 comma negative 4, and this will give you the correct combination. Okay. So as you factor, you're going to get x plus 1, x minus 4. So from here, you're going to get x equal to negative 1 and x equal to 4. Okay. And so these are your roots. Okay. So roots are your answers. Now let's say what happens if you were giving. So let's say if you're going backward. So when you're solving the equation, you're going through this, right? So what happens if you want to go backward? What happens if you get the answer and you want to get the equation? How will you do that? Okay. Well, if you notice that. Again, see this number. This number is the opposite of this. Okay, and again, this came from this. So again, you add to get the middle, and you multiply to get the last number, right? But notice that this is the opposite. So the equation that you get. Notice if you start out with this, right? So once you get the roots, what you do is from the roots you get your factor. So let's say if you have x equal to negative 1, x equal to 4, right? Now to get the equation, you have to go backwards. So from here, from this answer, you're going to get x plus 1. From this answer, you're going to get x minus 4. Okay, again, all we do is going backward, right? Then after that, you go ahead and multiply out using the FOIL method. So you're going to get x squared minus 3x minus 4 equal to 0, right? However, because this equal to 0 means you can multiply this by anything in front. So you can multiply by a number in front. So they can be any number, because when you multiply by a on both sides, so you multiply by a on both sides, so you get this, and a times 0 is equal to 0, right? So again, so this one is how you get back to that, right? Okay, so again, so these are the steps to get from the answer to the equation. Okay, and now the form is this. Okay, when you have, so if you notice over here, so you're going to get the relationship between the roots. So this is your R1, this is your R2. R means the roots or the answer. Okay, so the relationship between this is that A will be 8 times, and this would be. So this is actually, so this is going to, so if you go backward, this is actually x minus R1. So this is this. Okay, so. And this is x minus R2. Okay, so this is this. So you can R is your first answer, so this minus will give you that. So when you multiply out, this steps is x squared minus R1 plus R2 x. Okay. So again, we just try to generalize, okay, and plus R1 times R2 equal to 0. So this step is this step. So again, if you multiply, you get that. Okay? And when you add, you take the opposite, you get that. Okay? So what we did is we derive a formula to find the equation from the roots. Okay? Okay, so what we sum up is this. Okay? So the theorem from page 338 is that when you have a R1, R2, when you have R1 and R2 as your roots, then to get from R1, R2 to get equation, you use this formula. So you're going to get x squared minus R1 plus R2 x plus R1, R2 equal to 0. Okay, so you add the two roots together, you have to take the opposite, and then you multiply, you get that. So you add, you multiply. Okay. But this is like your basic equation. But there are many different possibilities. Depends on equation, depends on the condition. You also can have multiple of these. You can have a times x squared minus r1 plus r2 x plus r1 r2 equal to 0. So you can do that. Okay. Now the equation is fairly easy to memorize if you kind of recognize the pattern. So then we're going to write out the different degrees of the root equation. So for the x squared, you're going to, for the second degree, you're going to have x squared minus r1 plus r2 x plus r1 times r2 equal to 0. Now if it's a cube equation, when you got 3 roots, you're going to have x cubed, okay, minus r1 plus r2 plus r3. Again, the cube has 3 answers, right? Become x squared. It become plus, and then you're going to have a r1 r2, okay, plus. I'm going to write big so I don't run out of room. Plus r1 r3 plus r2 r3 x. Okay, so the pattern is this. So it'd be plus minus plus minus. Okay, and this would be r1 r2 r3 equal to 0. Okay, so here's your pattern. The pattern is the x. So you're going to get x3, x2, x1, x0, right? And the pattern would be always plus minus plus minus plus and so forth, alternating. And the roots would be, there would be no root at a time. So you take none at a time, you have 1 at a time, then you're going to get 2 at a time, then you're going to get 3 at a time. So this is the pattern. So if you do the x to the 4th power, so it'd be x, okay, so plus minus plus something x squared minus something x plus something equal to 0, right? So again, x to the 4 power, x to the 3 power, x to the 2 power, x to the 1 power, x to the 0 power, right? And it can be plus minus plus minus plus alternating. Okay, now over here, the coefficient, this one is when you take none at a time, so there's nothing over here. Over here, do 1 at a time, so, and there are 4 of them, right? So it would be r1 plus r2 plus r3 plus r4. Again, you do only 1 at a time and get all 4 of them. Over here, you're going to do, so you can none at a time, do 1 at a time. Over here, be 2 at a time. So it'd be r1, r2. Again, make sure you follow the be organized. So it'd be r1, r2. So start with 1, and you go r1, r2, and r1, r3, r1, r4. Okay, now we're done with all the 1s. Then you start with a 2. So it'd be r2, r3, r2, r4. So now you're done with the 2. Then you go r3. Okay, and that's all the combinations. Okay, now over here, so you go none at a time, 1 at a time, 2 at a time. Over here, you're going to do 3 at a time. Okay, so it'd be r1, r2, r3. So 3 at a time. Now this one is easier to do the one that's missing. So over here, missing the 4, right? R4. So now you're going to missing r3, and then you're going to missing r2, and you're going to missing r1. Okay. So again, you take none at a time, take 1 at a time, take 2 at a time, take 3 at a time, or if you take 4 at a time. Okay? Now, most of the time you will stay with the square. Once in a while, if you're on the math team, you compete. Sometimes you have to use the cube. Okay? And very rarely you have to do the 4. Okay? This, you probably never come across these. Okay? But this would be useful. Okay, it comes in handy when you compete in a math meet, for example. But again, this is the pattern. Okay, again, you start with whatever the power, so you alternate. So like the 4th power would be x to the 4, x to the 3, x to the 2, x to the 1, x to the 0, and the sign would be positive. It always start with positive. So plus, minus, plus, minus, plus, and so forth. Okay, and the roots would be take none at a time. You take 1 at a time, take 2 at a time, take 3 at a time, take 4 at a time, and you get all the combination within that. Okay? So that is your root formula. So for the algebra 2, the only one you have to memorize is this one here. So you have to know this one here. Okay? and also the multiple of this when you multiply by a. Okay, so let's go over some examples. Example 1, it says find the quadratic equation with the roots. So what you want to do is you want to write down R1 equal to 2 plus I over 3, and R2 equal to 2 minus I over 3. So what you want to do is first you write down the formula right away. Okay? So you're going to have an x squared minus R1 plus R2, x plus R1, R2 equal to 0. Then you substitute in here, so you get x squared minus, okay? Okay, so when you add this over here, the plus I and minus I will cancel out. So this will cancel out. So you're going to have a 2/3 plus 2/3 will give you 4/3. Okay? Now when you multiply, these are conjugates. So when you multiply, you just multiply the corresponding part. So 2 times 2 is 4. Plus times minus is minus. I times I is -1, so become plus 1. 3 times 3 is 9. Okay? And so now you go and simplify. Okay, so notice normally when you do an equation, you want to get rid of a fraction. So you want to multiply by common denominator. So common denominator is 9. So you want to multiply everything by 9. Okay? So this becomes 9x squared minus, and this will cancel out, become minus 12x. This cancel out, become plus 5 equal to 0. And that's your equation. Okay? Okay, so you can write down your formula and just match everything and just substitute, and that's your answer. Okay. Now, let's go to the next theorem. Let's say so this is like when you don't have a number in front, but if you have a number in front, like you have ax squared plus bx plus c equal to 0, in order to use this formula, you have to get rid of the a. So in order to do this, you have to get rid of that. So you have to divide everything by a. So you got x squared plus b over a, x plus c over a equal to 0. Then you write down that formula. Then you can do the matching. So this and this, notice sign is opposite. So in this case, R1 plus R2 equal to negative b over a. Okay? And this one, R1 times R2 equal to c. Okay, so that's what the theorem is saying. So what it's trying to say is that when you have a number in front, you have to divide to get rid of the number in front before you use this formula. Okay, okay, let's go to example 2. It says find the roots of 2x squared plus 9x plus 5 equal to 0. Find the roots and check your answer by using the theorem of the sum and the product of the roots. Okay, so this is not factorable, so you have to use quadratic formula to find the roots. So a equal to 2, b equal to 9, c equal to 5. So x will equal to negative b plus or minus square root of b squared minus 4ac over 2a. So x equal to negative 9 plus or minus square root of 81 minus 40 over 4. So x will equal to negative 9 plus or minus square root of 41 over 4. Okay? So in this case, your R1 equal to negative 9 plus square root of 41 over 4. R2 equal to negative 9 minus square root of 41 over 4. Okay, okay, so now they want you to check your answer. So this is the first part, find the roots. Okay. Now they want you to do the second part, check your answer by using the theorem about the sum and the product. Okay, okay, well, sum, so R1 plus R2. Okay, so the sum, when you add this together, again, this will cancel out. So you're going to end up with negative 18 over 4 when you add. Okay, so R1 plus R2 will equal to negative 9 over 2. Okay, and again, if you notice when you divide, if you divide this by 2, okay, divide this whole thing by 2, you're going to get x squared plus 9 over 2x plus 5 over 2 equal to 0. And when you write the equation, x squared minus r1 plus r2, x plus r1, r2 equal to 0. So you can see that r1 plus r2 equal to negative 9 over 2, so it checks, right? See that? Okay, so I'm going to move this. So again, so that's what that is. So now you product r1 times r2, you want to check, see if this is correct. So when you multiply, so negative 9 times negative 9 is 81, plus times minus is minus, square root of 41 times square root of 41 is 41, 4 times 4 is 16. So r1 times r2 equal to 40 over 16, and you simplify, divide by 8, you get 5 over 2. And again, that's what that is. See that? When you match, r1, r2 matches 5 over 2. Okay? So that means it checks. Okay? So again, this is how the roots and equation coefficient of the equations are related. Okay, let's go to example 3. Okay, you're looking for a quadratic function such that f of x equal to ax squared plus bx plus c, such that the maximum value, so again, if you sketch, the maximum value of f is 8, and the x-intercept are 3 and 7. Okay, so if you sketch it out, so this is 1, 2, 3, 4, 5, 6, 7. So this is your x-intercept. Okay. Now, remember the quadratic is nice thing about quadratic is a symmetrical. Okay, and maximum height is 8. So the maximum height is going to be right over here. Okay, and how do I know that? Well, this is 3, this is 7. So if these two are intercept, the axes will always halfway in between. So you average 3 plus 7 is 10 divided by 2 is 5. So this is going to be a 5 right over here. So axis is going to be 5. So this point has to be 5 comma 8. Okay, because this is your vertex. Maximum is your vertex. Okay, so your graph is going to be like this. Okay, so again, from the intercept, you can find the middle, the axis, and from the axis, you can find the vertex. Okay. Okay, so that's kind of the things right away. Okay, but before you do anything, okay, so if you were to, so let's go and let's go and make this into, okay, let's go and divide everything by a first, okay. So remember, let's just focus on this part, okay. So let's go and write the equation part, the root part. So remember the equation. So the root equation is x minus r1 plus r2, x plus r1, r2 equal to 0, right? That's your basic equation. So your intercepts are your roots, okay? So that's your r1, r2. Okay, so again, your x-intercept are your roots. That's when y equal to 0. So you can put this in here. So x squared minus, so r1 plus r2 will equal to 10. When you multiply, you get 21. Okay? So this equation becomes f of x is equal to a times, there's a multiplier, right? So equal to a times x squared minus 10x plus 21. Okay, so that's what that is. Now to find this a, we have to use this 5, 8. Okay, so that's your x and the y. So x is 5 and the y is 8. So let's go off to the side so we don't mess up the whole equation. So you're going to go off to the side, so you're going to get 8 equal to a times x squared minus 10, x is equal to 5. Okay, so again, x equal to 5, y equal to 8. So x equal to 5, y equal to 8. So 8 is equal to 8 times 25 minus 50 plus 21. So 8 equal to 8 times negative 4. Okay. then you divide by -4, divide by -4. So a equal to -2. So once you know a equal to -2, you can put it back over here. So f of x equal to -2 times x squared minus 10x plus 21. Okay. So that's your equation. So you can use your root equation to get your basic equation, and then from there you can use additional information to find your multiplier. Okay, on page 341, example 4, so the automobile dealership sells only 35 new cars per month when markup over factory price is 3,000. Okay, so n equal to 35. So n is the number of new cars, and the price is equal to 3,000. Okay. Market research indicates that for each $200 decrease in the markup, okay, the dealership can expect to sell additional 5 cars. Okay, so you're going to get 35 plus 5 times how many times the increase, okay? And so x is how many times it increase. So every increase, every change. Okay, that's going to use d as the change. Okay. So the number of cars. So every time it change, it will increase by 5, and the price will be minus 200d. So d is how many times it change. So every time when they change, it decreases by 200 and it will increase by 5 cars. Okay. Okay, so what should be markup per car in order to maximize the total monthly profit? Okay. Okay. So the price you're going to set would be equal to, so the total profit would be the price times number of cars, right? Okay, so P of n, so price, so in the book you use n, so let's go and use a small n then. So n is the number, so don't get confused big N and a small n. Okay. Okay, so it's going to be the price, the markup, times the number of car. So you can mark up times number of car, there would be the total profit. Okay. So again, the profit equal to the markup times the number of cars. Okay. So when you multiply out, use a distribution. So you're going to get 105,000 plus 8,000 n minus 1,000 n squared. So foil it out, multiply out. Okay. And to find the vertex, see when you have a quadratic equation, okay, I'm going to switch it around, so it'll be negative 1,000 n squared plus 8,000 n plus 105,000. Okay. Now, when you have a graph, okay, whether it's this way or this way, this point, the vertex, the coordinate of the vertex is negative b over 2a, and there's something else that you can figure out later. Okay, so the vertex, the coordinate of the vertex for the x is negative b over 2a. Okay, so that's your x. So over here, so the maximum that you need to get, okay, so negative b over 2a will equal to negative 8,000 over 2 times a and this will equal to 4. Okay? So that means when n equal to 4, we give you the maximum profit. Okay? So P of 4, when n equal to 4, this will give you the vertex, or the maximum or the minimum, depends on the situation. Okay? So you're going to get negative 1,000 times 4 squared plus 8,000 times 4 plus 105000. So P of 4 will equal to 121000. Okay, so your maximum profit is 121,000. Okay, and n equal to 4 means you want to mark up 4 times. So if you want to find out what the markup is, okay, so over here they use, okay, let's go and use m for markup. Okay, so the markup will equal to this over here. So use the m for markup. So it would be 3,000 minus 200 times n, which is 4. So the markup would be 2,200. Okay, so so markup of 2,200 will give you the optimum. Okay, so bottom line is this. Okay, the vertex, to find the x coordinate for the vertex for the minimum or maximum is negative b over 2a. So that is the key for this over here. Okay, so that's your maximum or minimum. That's going to be the vertex.